In this lab, we will continue with the time series data analysis of the public transport network in Auckland. In the previous lab, we showed what we did was that we included seasonal component in the trend with the trend, and we plotted the actual pre-COVID and the actual post-COVID data, and we also plotted the forecast the trend values for the pre-COVID data frame, the trend values, and the predicted values for the post-COVID data. And we also plotted the upper limit of the forecast and the lower limit of the forecast, and we shaded the area in between the upper limit of the forecast and the lower limit of the forecast. And the graph, the plotted graph showed that the actual post-COVID data were much lower than the forecasted post-COVID data. Now in this lab, we will calculate the difference in passenger numbers between the predicted values, and the actual passenger numbers recorded by the Auckland Transport post-COVID data frame. So the task: use the post-COVID data frame and the results from above, the forecasted results and the trend values and the so use the post-COVID data frame and the results from above, and compute the difference between the predicted and the actual data. Then plot the shading between these lines. Plot the shading between these lines, and assume a profit margin. Pay public transport user to calculate Auckland Transport loss of revenue during COVID. Assume a profit margin. Pay user parameter of $1. So calculate the difference between predicted and actual passenger numbers. So we have the post-COVID data frame, and we have the actual passenger numbers in thousands column, and we have the predicted passenger numbers that is forecast with seasonal. So what we will do is, assuming actual passengers column has the actual passenger numbers, let post-COVID of the new column difference equal post-COVID for the column forecast with seasonal minus the passengers in thousands column, and printing the post-COVID, we get this. So you can see the difference, which is the forecast with the seasonal, the predicted values, which includes the seasonal values, minus the passengers in thousands. Okay. Step 2. We plot the difference with shading. Hence, you can use the fill_between method in Matplotlib to shade between the actual and predicted values. So plt.plot of post-COVID.index, so that's on the horizontal axis, and those are the month and year, comma, post-COVID forecast with seasonal, so these are the predicted values, and this will be shown on the y-axis, and the color is K, and the line type is dash dash, comma, line width equal 1.5 and label equal prediction. So let's plot only that. And let's plot only that. And we see that this this line graph is plotted. Now let's put the color and the line style and the line width equal 1.5 and the label equal predicted. So this is what the line graph looks like. And then let's do plt.plot of post-COVID.index. So that goes on the horizontal axis, comma, post-COVID of passengers in thousands, that's on the vertical axis, and the line style we want to show what it plots first. So let's do that. And so we have this bottom line over here. These are the actual values, which is passengers in thousands, and the upper values are the predicted values, which is now. So let's delete this. So let's put color equal K and the line style is dash, line width equal 1.5 and the label equal actual. So let's run this and we get this. Then let's pass the command. Let's add to the plots plt.fill underscore between of post-COVID.index, comma. So the horizontal axis is the post-COVID.index, and the fill between will be in between post-COVID of passengers thousands column and post-COVID forecast with seasonal column. So let's do that. Let's run this, and we see that the region in between the forecast values and the actual values are shaded. Let's change the color, color equal K, comma, alpha equal 0.15. So alpha is the how light is the color, how bright is the color. So let's run that, and we see that the color is changed to K. And so let's put the horizontal axis label. Here's a plt.x label of time, and y-axis label, which is plt.y label of passenger numbers. Then let's add the title, plt.title of difference between predicted and actual passenger numbers post-COVID. Then let's do the legend by passing the command plt.legend open and close bracket and plt.show open and close bracket. So we see that the title is here, difference between predicted and actual passenger numbers post-COVID, and vertical axis is labeled as passenger numbers and horizontal axis is labeled as time, and the dashed lines is the shows the predicted line graph, and the continuous line shows the actual passenger numbers, and the region in between is shaded. Now step 3, we will calculate Auckland Transport's loss of revenue. Assuming we have a variable profit margin per user that represents the profit margin per public transport user, we can calculate the total loss as. Okay, so here profit margin per user equal 1. So first we compute the total difference between the total difference where the predicted value is greater than actual value. So that is loss of passengers. So we can see that from the graph here, all the predicted values are more than the actual values. So there is loss of passengers in the post-COVID. So let total loss of passengers equal post-COVID dot log for location and square bracket post-COVID of difference is greater than 0, comma column difference dot sum, open and close bracket. So okay, so yeah. So we have post-COVID difference column, which is this one, and we want it to be greater than 0. The difference to be greater than 0. So looks to be true. Now let's look at the post-COVID. And we want to read all the differences which are greater than 0. So dot log square bracket, and here we'll put the comma, and the column is difference. So we want all the values, all the difference values that are greater than 0, and that prints this. So now we will take the sum, and this will find the sum of the differences that are greater than 0, and that comes to 152,086. So that's what we're doing in this command. Total loss of passengers equal post-COVID dot log square bracket post-COVID square bracket difference. So that's the column difference greater than 0, comma difference dot sum, open and close bracket. And when we run that, we get 152,086. Then we multiply by the profit margin per user to get the total loss of revenue. So let total loss of revenue equal total loss of passengers, which is the number that we got over here, 152,086, times profit margin per user. And we already were given profit margin per user of $1. So we will use that. And that gives a total loss of revenue of $152,086. Print bracket, we'll put the F because we have Kelly braces inside this comment. So F and then we'll put the what we want to type. So total loss of revenue during COVID, colon, and then we have a dollar sign, then in bracket we have total loss of revenue. Close the curly braces and close the curve bracket. So in place of the total loss of revenue, that actual total loss of this value will be put in there. So total loss of revenue during COVID, colon, $152,086, 5 cents. Let's round this to 2 decimal place. So numpy dot round of total loss of revenue to 2 decimal place. Close the bracket. So that rounds the value to 2 decimal place. So the total loss of revenue during COVID is $152,086 at 5 cents.